question, is the new particle really a Higgs boson? And Atlas and CMS, the two experiments, have meanwhile verified the fingerprints. Yeah? So first of all, if this beast is the messenger of this field which gives mass to elementary particles, it should talk to each particle depending on the mass of this particle. So the more massive these particles are, the more it should talk to it. The less massive, the less it should talk to it. And this follows exactly this line, which is expected. In particular here, the very good measurements with these heavy particles here. So that, yes, the answer is it talks to them with a strength proportional to their masses. Secondly, is it a scale? Is it representing a scalar field? That means without any preferred direction. The answer is yes, to a very, very large extent. Yes, the spin is zero. It is representing a scalar field. So we could, in March last year, announce, yes, we have a Higgs boson. It completes our standard model, and thus it helps to describe 5% of the universe. So we have completed the standard model with the Higgs boson now. And Stockholm realized it, and this is a picture from Boson Higgs and Peter Higgs. And important for us, of course, is a green text saying, confirmed through the discovery of the predicted fundamental particle by the Atlas and CMS experiments at the Large Hadron Collider at Cern. So we did not get the Nobel Prize, but we are inside. Okay, so that's perfect. That's fine. And there's another reason that we had to find this particle. These guys, they wrote their articles independent from each other around 50 years, now today 50 years ago, 1964. The first time these two guys met was on the 4th of July 2012. So we had to find this particle, otherwise they would never have met. But that shows you also that they are pretty moderate and they are very nice chaps. So not going to too many conferences, more working with them. So now we have a Higgs boson, but that's only the beginning. Well, is Ilam here? Oh no.
No, it's good.
Ah, okay. So George, discovery is easy. Now comes the hard work, okay? What's next? We know it is a Higgs boson. But is it the Higgs boson of the standard model? Or is it one of several? Because whatever goes beyond the standard model, most of the theories predict more than one Higgs boson. And as is the case for families and bachelors, they behave differently. Let me just take the example of two. Let's say you know somebody who has a twin. And I use now the masculine sense, because I don't want to mix it all the time. Both look exactly the same. And the only difference you know between them is a certain word which they pronounce differently. So otherwise, everything you know about them is equal. Then somebody comes over there in the fog, looks very much like one of your friends. Come close and close, and then you can identify, yes, it's him or him. It's one. It's a friend, but not if it's the or the other. And this guy doesn't talk very much. You have to bring him to talking. Yeah. You have to talk to him. And at some stage, maybe, he pronounces the word which can distinguish him from his twin. That's the same here. So we have to measure a lot, and we have to identify the properties of this particle in order to find out, is it a single one, or does it have brothers and sisters? However, when we find its properties, the properties could give information on dark matter, because any deviation could be of the property predicted by the standard model could give information, could be caused by dark matter particles. Dark energy is a scalar, the Higgs boson is a scalar, so the properties could maybe give first hints of the behavior of such scalars of dark energy, for example. So, at least my understanding of the universe is about to change. So, in order to perform all this, we have a physics program at the LHC far beyond 2030, not only on the Higgs, but also on other possible measurements and hopefully discoveries, which I didn't have time to go into. But we have a nearly 20 years program in front of us. So, the past decades saw precision studies of 5% of our universe. That was the discovery of the standard model. The LHC delivers data, and we have a discovery. This is just fantastic. However, we are just at the beginning of exploring 95% of the universe. And I would say the future is bright in the dark universe. Thank you.